All right, so now that we know how to add, subtract, multiply, and divide rational expressions, let's take a look at one of the things we always do with everything is solve equations. Everything is about solving equations. Before we do that, however, I would like to spend some time kind of reviewing what we do with the lowest common denominator, or what we call the lowest common multiple, and the difference between when we deal with them in an expression or an equation. So let's take a look at that, and it'll build the seeds for what we're going to do throughout this particular section. So in mathematics, everything is about balance. Everything we do mathematically has to be in balance in somehow. And so when we're dealing with a fraction or an LCD, one thing that we use them for is to build an equivalent fraction. All right, so you guys have seen a lot of this lately in your homework, and I keep taking points away from you guys for not doing that. As a matter of fact, I didn't even think I spelled equivalent wrong. But this is not a spelling class. So at any rate, right, so when I have a fraction like 2/3, the balancing act that I play with an LCD or any denominator is to multiply the top and bottom by the same thing. And that gives us 4/6. Of course, if needed, maybe I do 3/3, giving us 6/9. Or if needed, I do 4/4, giving us 8/12. So the idea is we multiply by some form of 1. The balancing act is whatever I'm doing at the top, I'm doing the same thing to the bottom. The number divided by itself is 1, so this is still 2/3. And this is still 2/3, and this is still 2/3. It's just written in a different way. The picture would be different. So, 4 out of 6 pieces is the same ratio as 2 out of 3 pieces. So one of the balancing acts that we play is doing the same thing to the top and the bottom, right? This type of balancing act is needed when we're working with an expression and we're trying to simplify it, all right? So when we look at this expression here, the two terms that are like need to be added together, right? So we have 1/6x plus 1/2 x, and then these two terms don't have an x, so they would be like. So I'm trying to combine like terms here. I'm essentially trying to add fractions and add fractions. So what balancing act do I need? I need the equivalent fraction balancing act. So here the LCD is 6. This one already has it, so I'll leave it alone. This one I would need to multiply by 3/3 to accomplish it. For these two fractions, the LCD is 12. So I would need, this one already has it, so I'll leave it alone. And this one would need a 3/3. And then continuing our work, right? These two now are 1/6x plus 3/6x. And this is minus 5/12 plus 9/12. And now that I have the same denominator, right, we keep it and add up my numerators. Or in this case, we keep it, I think -5 plus 9 is 4, and add up my numerators. Okay, so again, key thing is the balancing act that we played, right, in trying to create an equivalent fraction so I can actually simplify the expression. Last thing to do in this side would be to put it in lowest terms. So there's how we simplified that expression by combining like terms. I'm adding and subtracting fractions. So the balancing act I need is multiplying the top and the bottom by the same thing, some form of 1. Solving equations is differently, right? When we're solving an equation, the balancing act, how about we put an equation up here, right? The balancing act that we play for an equation is whatever I do to one side of the equation, I have to do the exact same thing to the other. So, in this case, if I was solving that equation, I would subtract 3 from both sides, giving us 2x equals 8. And then the next balancing act is I would divide both sides by 2, giving us a final answer of x equals to 4. So the balancing act we play for an equation is, I think I playfully called that the golden rule. Whatever you do to one side of the equation, you have to do the exact same thing to the other. And that actually turns out to our advantage when we're solving an equation with fractions in it, right? Because I'll still find the LCD. So the LCD of the whole problem in this case is 12. And then what I'm going to do with it is I'm actually going to take both sides of my equation, because again, the golden rule is I can do whatever I want as long as I do it to both sides of the equation. I'm okay. But notice the balancing act is different than over here. Here we're multiplying top and bottom by what I needed to get the LCD to create an equivalent fraction. Over here I have an equation, and my balancing act is to use it to both sides. And the payoff, if we distribute here, this will give us 12 6x minus 60 over 12, right? So we're 12 over 1 if you would. And this would equal 12 over 2x plus 36 over 4. And that doesn't look great, but if you take a look at each fraction, this becomes 2x, that becomes 5, that becomes 6x, and that becomes 9. And I don't know about you guys, but I would much rather solve this equation without fractions in it than this equation with fractions in it. So the moral of the story is that because of that equal sign, I have a lot of power. I can do whatever I want to both sides and still be equivalent. So I'm going to take advantage of the LCD, multiply both sides by it. That clears the fractions, and now, right, my work is probably easier to do. So we'll subtract 4x from both sides and add 5. That cancels some stuff out. And, oops, I meant 6x. So we'll subtract 6x from both sides. We end up with negative 4x equals, it looks like, 14. We would divide both sides by negative 4. Check out my balancing act. I'm doing the same thing to both sides. And we get a negative 14 over 4. And of course, if we divide both downstairs and topstairs by 2, we get the final answer of negative 7/2. So this is the game we're going to play throughout Chapter 6. Since we're solving equations with fractions in it, the idea was we'll find the LCD, multiply both sides by it, that'll clear the fraction, and then we solve the equation that's left. Don't confuse that with the balancing act that we use when we're actually trying to add and subtract fractions. There we multiply by 1. And of course, if you were, dare I say, sadistic, you could do the same thing here, right? You could literally try to find the LCD and play this balancing act and move things around and work with the fractions. If you're strong with fractions, go for it. Otherwise, you're going to see me continually, right, take advantage of the equal sign, and I'm going to be multiplying both sides by the LCD to clear them so I can work with what's left. All right, so we'll see that in action in the next few videos.